There are two special triangles which we are going to use a lot during this course. Now we'll start with this equilateral triangle with sides of 2 centimeters. I'm going to split the triangle into 2 equal parts with a line down the middle here. I'm going to call the height x, and of course this distance is now 1 centimeter. This angle is 60 degrees, and of course this angle is now 30 degrees. Now we calculate x using Pythagoras' theorem. X squared plus 1 squared equals 2 squared, so that x squared is plus 1 is going to be 4, and of course x squared equals 3. Now x equals root 3, which I'm going to leave as a third. Now this is the special triangle that I was referring to, and we must learn that triangle, because from this triangle we can just read off the trigonometric ratios for 60 degrees and 30 degrees. For instance, let's take this angle 60 degrees and find sine 60. Sine is the opposite over the hypotenuse, so sine 60 is root 3 over 2. Similarly, sine 30 is its opposite, which is 1, over the hypotenuse, which is 1 over 2. And there are the values. Now let's find cos 60. Cos 60 is the adjacent over the hypotenuse, so it is 1 over 2. And looking at 30, cos 30 is its adjacent over the hypotenuse, which is root 3 over 2. And there are the values. Now tan 60 is opposite over adjacent, which is root 3 over 1, or just root 3. And tan 30 is its opposite over its adjacent, which is 1 over root 3. There. Now normally we rationalize the denominator when we have a root 3 on the bottom, and we multiply by root 3 over root 3, which produces root 3 over 3. Now, you must learn this triangle. We don't learn these answers, we read these answers off the triangle. So you must know what the triangle is. In fact, the triangle is given to you on the formula sheet as well. This is the second special triangle, and it has 45-degree angles because it's isosceles. Both sides are 1, and these two angles of course are 45 degrees. Now I'm going to work out the hypotenuse again using Pythagoras' theorem. X squared equals 1 squared plus 1 squared, and so x squared is 2, so x equals root 2, so the hypotenuse is root 2. Now we read off the values as before. For instance, tan 45 is the opposite over the adjacent, so tan 45 is 1 over 1, or just 1. Similarly, sine 45 is the opposite over the hypotenuse, which is 1 over root 2. And in fact, cos 45 is the adjacent over the hypotenuse, which is also 1 over root 2. So sine 45 and cos 45 are both 1 over root 2. And again, when we rationalize the denominator of this, we put root 2 over root 2, which produces root 2 over 2. Again, learn this triangle so that we can know these values whenever we use them.